Hello and welcome back to ACER Explained. In this series, I'm going through Section 3 of the ACER Practice Test booklet. In this video, I'm going through questions 41 to 43, so that's Unit 12, and I'm also going to be identifying the prerequisite knowledge that you need, as well as the reasoning skills that are used and the bootcamp resources that can help with this. So in this unit, we're basically given some information about organic compounds and conjugated bonds. So conjugated bonds are basically alternating single and multiple bonds. So it could be triple, this could be double, as long as these are multiple bonds alternating with these single bonds, you have conjugated bonds. So that's what that means. And then you're basically told as well that the greater number of these kinds of groups in a molecule, the longer the wavelength is going to be that can be absorbed. And so that relates to our question 41, because question 41 is asking which of the following groups, if you attach it to a benzene group, would not increase the wavelength at which the maximum absorption occurs. So increasing the wavelength, you will increase the wavelength when you increase the number of conjugated bonds. Okay, and so we're given this structure. That's a terrible hexagon. Let's start that one again. So we're given this structure here. There we go. And we're basically told that adding to the benzene groups here, which of the following compounds would not increase the wavelength? So we're looking for a group that does not have conjugated bonds, right? So let's say we have our benzene group here. And let's start off with the carboxylic acid group. You do need to know your basic chemistry in terms of your carboxylic acid, nitrile, and alkyl groups. So here you can see that this double bond is being followed by a single bond, which is followed by another double bond. So that is conjugated. So that is going to increase the wavelength. And because we're looking for something that's not going to increase the wavelength, we can eliminate this option. So now I'm going to bring out my eraser and do the same exact thing, but with the nitrile group. So we have the nitrile group, we have C, and then that's a single bond, triple bond, and N. So because that is conjugated, it's going to increase the wavelength. And so we can eliminate this option as well. And then again, I'm going to do the same thing with our alkyl group. And so an alkyl group is basically a chain of carbons and hydrogens that consists of single bonds. So this could be CH3, this could be CH2 attached to a CH3, etc., etc. It could go on and on and on. And so this alkyl groups don't contain any double or triple bonds. And so this means that there's not any extension of the conjugation, which means that the wavelength is not going to be increased. Okay, and so you can confidently circle C as your correct answer without even knowing what an aryl group is. An aryl group is a little bit more advanced organic chemistry. It could be helpful if you do know this, but having that basic knowledge of these three groups is going to be sufficient to be able to answer this question. For this question, you did need a little bit of prerequisite knowledge on organic chemistry and those basic carboxyl, nitrile, and alkyl groups. The reasoning skills we used here were the process of elimination, as well as being able to derive the important information from the passage. And the bootcamp resources that can help with this are the reasoning skills course, as well as the bridging course on organic chemistry for that prerequisite knowledge. Question 42 is asking us about beta-carotene, and I've just drawn the structure of beta-carotene here, and we're given that information as well. And it says, it's asking us why it's orange, okay? And so let's go through the options. This molecule has two 6-membered rings that absorb at the red end of the visible spectrum, or it has two 6-membered rings that absorb at the blue end of the spectrum. So these two options differ in this sense. Then we have two other options that are similar. So a set of 11 conjugated bonds that absorb at the blue end of the visible spectrum, and a set of 11 conjugated bonds that absorb at the red end of the visible spectrum. And so here we have two aspects of the answer option. We have the reason why, and we have what it's actually doing. So first, let's look at the reason why, because we're actually given this information. So it says in the stimulus that the reason that some compounds are colored is because they have groups that usually contain conjugated bonds. All right, and so that's how we can eliminate option A and B, because the reasoning that they've given here doesn't match with the reasoning in the stimulus. The stimulus is talking about conjugated bonds, and so those are the options that we're going to look at. And then we have what wavelengths they're absorbing. So why is it orange, right? Is it because it absorbs the blue end of the spectrum, or it absorbs the red end of the spectrum? So it's helpful if you have some knowledge on the light spectrum, but even if you don't, you can kind of infer if a compound is absorbing the blue colors, then that means it's likely going to be reflecting the opposite end of that spectrum, right? And so something that's absorbing the blue end of the spectrum is not going to look blue. Same thing here. If something is absorbing the red end of the spectrum, it's not going to look red. It's going to look anything that's not red. Usually the opposite end of the spectrum would be reflected, right? So because orange is quite close to red, and we know that if red is being absorbed, if the red end of the spectrum is being absorbed, the compound is not going to look red, right? Because that color is being absorbed, not reflected. So we can eliminate this, and the blue part of the visible spectrum is actually opposite to the orange end of the visible spectrum. And if you knew that, you'd be able to kind of circle C almost immediately without eliminating D. But even if you didn't know that, you can still eliminate D using the reasoning that I provided just now. So like I said, it's helpful to have some of that knowledge on the light spectrum, and the reasoning skills that were used here were being able to extract the important information from the stimulus and then be able to apply that to find the correct answer. And also we use the process of elimination here as well. So the bootcamp resources that can help with this are the reasoning skills course, the acceleration class on introduction to reasoning, as well as the bridging course on optics and light for some of that prerequisite knowledge. Question 43 is asking us about phenolphthalein, which is an acid-base indicator. We're given two diagrams here, and one is the structure in a high acidic environment, and the other is a structure at a low acidic environment, and we don't know which one is which. And the question is asking us which of the following options are true. So we have two different aspects to our answer options. We have the pH, and then we have whether or not the compound is colorless. So let's start off with the colorless bit. So we're told from our stimulus that the color comes from conjugated bonds in these kind of compounds. And so if we look at our options 1 and 2, then we can see that option 2 has these conjugated bonds. It has a longer chain of these conjugated bonds. So we have, for example, from here, we have a multiple, single, multiple, single, multiple, single, multiple, single, multiple, single, multiple, single, and even if we go back this way as well, we have single, multiple, single, and then we continue the chain that way. Then we also have, going down this way, single, multiple bond, a single bond, a multiple bond, and this C is actually COOH, so, well, COO, and so this is also single leading into a multiple. Whereas if you look at option 1, this only exists in kind of these isolated rings. So if you were to pick which of these would be colored versus colorless, this is likely the one to be colored. And so you can say that these options can be then eliminated because these structure 2 is likely to be the one that is colored, and structure 1 is likely to be the one that is colorless. All right, and So we are given that information that it's either colorless or pink, so we have to choose between one or two. That's why we're choosing the one that's most likely to be colored versus colorless. All right, so we can eliminate these two options down here. Now all we're left to decipher is whether or not structure 1 is going to occur at a low pH or a high pH. And you need to bring in those principles of acid-base chemistry here. So you have in an acidic environment, so low pH, you're going to have a lot of protons floating around, okay? And so using kind of your Le Chatelier's principle, if you have a kind of solution that already has a high amount of a particular product, that's going to push the reaction backwards. So it's going to lead to less hydrogen ions being dissociated. So that means our reactant is going to have, we're going to have more of the structure with the hydrogen atoms still attached to that structure rather than dissociated. So for example, if you look at the structures carefully, you can see that over here, you've lost the hydrogen. Over here, you've lost the hydrogen. And in our, I've just missed a bond here as well. You've also lost that hydrogen there. So going from structure 1 to structure 2, you're essentially, let's pretend this is an R group. You have your H. You're losing that R group. Sorry, you're losing that H, and you're left with a negative charge. And because you've lost that H, it becomes a proton. It's being ionized, right? So this reaction is more likely to move forward from compound 1 to compound 2 if you have less hydrogen ions in solution, right? Because if you have less of this, then your reaction will be pushed towards that direction, and that's according to Le Chatelier's principle. Now, if you already have a lot of this, then this is going to be smaller or even pushed towards that side. So if you have a lot of this hydrogen ion, then your reaction is going to be pushed towards the opposite direction. So you'll have more of compound 1. And so that's how you can kind of say or decipher that in a condition that has lots of hydrogen ions, you're going to have lots of this structure, I, right? And having lots of hydrogen ions means you have a lower pH. And so that's your basic acid-base chemistry principle as well. And so that corresponds to answer option A. So the previous knowledge that was needed for this question was just your acid-base chemistry principles, and you also used the process of elimination to get to the correct answer. So the bootcamp resources that are helpful for this are the reasoning skills course, the acceleration class on introduction to reasoning, and then also the bridging course on equilibrium and acid-base chemistry in order to refresh that prerequisite knowledge. So that brings us to the end of this unit. Please like, share, and subscribe for more GAMSAT help. We really appreciate all of your feedback. We have our Instagram at Thank Flip GAMSAT and our podcast, Thank Flip GAMSAT Nurses Doing GAMSAT as well, if you want to hear more from us. And yeah, I'll see you in the next one.